Okay, 4.5, we're going to do the rational root theorem, which along with the factor theorem is going to help us to factor higher degree polynomials like these. They can't be grouped or anything else. Okay, don't copy this down. Okay, now at the top I've written some random polynomial. I don't know what's going on in the middle, but I want to figure out the factors for it. Okay, now this is x cubed. So it's gonna have up to 3 factors probably. Since it's x cubed, I know it's gonna be x times x times x. Now since this last number is 20, it could be like 4, 5, and 1 here. That would work, but that's not the only way that could work. It could also be like, maybe it's 2, 2, and 5. Maybe there's a 10, a 2, and a 1. There's a bunch of combinations that might work. We need to figure out which one works. Okay, so this brings us to the rational root theorem. Okay, rational root theorem says if f of x is a polynomial with integer coefficients, meaning no decimals, no fraction, then every rational zero of f of x has the following form. The rational zeros are going to be the factors of a prime. A prime's the last term. When we did that fake example, we looked at the last number and the numbers had to multiply to equal to 12. So that's the last number. Okay, if there happens to be a coefficient in the front here, we divide by the factors of the front term. Okay, so for example 6, we're just going to list what the possible rational zeros are. We're not actually going to figure out which ones are correct. We will use the factor theorem to figure out which ones are correct. Okay, so first, to figure out the possible rational zeros, I'm going to look at the last term. That's this minus 12. Now, what could I times? What are the factors of 12? It could be 1. Could be 12. 1 times 12. What else? Could be 2. Could be 6. Could be 3. Could be 4. Is that everything? Okay, the other thing is it could be a positive or a negative, because it could be a negative 3 times 4 times 1, or a 2 times 2 times 6, or negative 6 or something like that. So to include positives and negatives, we put plus and minus. Okay, this keeps in account everything that could be multiplied to get negative 12. Okay, now if I look at the first term, there's no coefficient in the front, so I'm not going to worry about the first term. Okay, these are all the possible rational zeros, which would help us find all the possible factors. Okay, let's go ahead and look at B. Okay, this is a giant pot. We just want to look at the last term and figure out what possible zeros there are, even though we're not yet confirming which ones are correct. Okay, so for 10, what could we do? We could do 1 times 10. We could do 2. We could do 5. Is that everything? And it could be positive, negative. Even though it's a positive 10, it could be a negative times a negative. That would turn it back to positive. So we're just going to include positives and negatives for all things. Since there's no coefficient on the first term, we're not going to worry about that one. Okay, now C is going to have a first term, but let's figure out the last term first. Okay, possible rational zeros. I'm going to look only at the last term to begin with. So the last one's 3. Okay, so what can I times? I could do 1, I could do 3, but it could be positives and negatives again. Okay, now in this case, there is a first term. It's 2. Okay, so I want to do the factors of the last term divided by the factors of the first term. The first term is 2, so what do I times to get 2? It could be 1, it could be 2. Okay, so the possible rational zeros are every combination of those top terms divided by the bottom term. So let's say I do 1 divided by 1. Well, that's 1. What if I do 3 divided by 1? That's 3. What if I do, let's see, 1 divided by 2? That's 1/2. If I do 3 divided by 2, that's 3 over 2. And these could all be positive and negative because they could be mixed and matched. Okay, these are all the possible rational zeros. Okay, the reason we're getting fractions here is because there's a number here, which means one of my factors might be 2x plus 3, it might be 2x minus 1, and when I solve it, I'm going to get a fraction. If there's a number in front, you could get a fraction. Okay, D is similar. Let's look at D. Okay, start out, just look at the last term. Okay, it's 4. So what could I times to get 4? Let's see, I could have 1 times 4, I could have 2 times 2, I don't have to list it twice, and it could be positive and negative. Let's go ahead and look at the leading term, leading coefficient. because there could be fractions if there's a number. What do I times to get 5? It's 1 times 5. Okay, now I need to do every combination of the top ones over the bottoms. So I'm going to do 1 divided by 1, which is 1. 4 divided by 1 is 4. 2 divided by 1 is 2. Okay, let's do it over 5 now. 1 divided by 5, 4 divided by 5, 2 divided by 5, and then these could also be positive or negative. Okay, these are all the possible zeros to the polynomial. It doesn't tell me which ones are correct though. I'm just guessing what's possible. Okay, now what good is this? Okay, this is useful so we can actually factor a polynomial all the way and find all the zeros when they don't give me one. Okay, so example 7, we're going to use the rational zero theorem to find a zero, and then we're going to find all the zeros. That means we're going to solve this. Okay, now you could try to group this first. This would be x squared times x minus 6. This would be 1 times 3x plus 7. There's no common factor, so grouping does not work. But it doesn't hurt to check because grouping is a lot less work. Okay, since they did not give me the first factor like we did in the last section, I'm going to list all the possible zeros. Now you don't have to list them every time, but you need to keep in mind what your list is so you know what to check for. Let me look at the last number. It's a 10. So what could I times? I could have 1, 10, 2, 5, and it could be positive or negative. Okay, now I need to figure out which one actually is a 0 for this to work. So I can either plug it back in or I can do synthetic. I'm going to do synthetic because I think it's faster for me. Now I don't know which one's going to work, so I want to just guess. Okay, when you guess, sometimes you might think, oh, I have an idea of which one's correct. Go with your gut, or I just guess the easier numbers first. Okay, let me bring down the 1. Now what number should we try first? Let's just try 1. See if it equals to 0. Okay, 1. 1 times 1 is 1. Negative 5 times, that's negative 5. 3 minus 5 is negative 2. 1 minus 2. No, that's not 0, so that's wrong. Okay, since that one didn't work, let me try another one. Now, you can just erase your numbers and change it once you see it's wrong. You can start over on the side. Since these are your notes, I'm going to show that I'm trying another one. Okay, what should we try next? Yeah, maybe negative 1, maybe 2. We'll try 2. If you want to try a different one than me, that's fine. Sometimes some of you might get it on the first guess. Okay, let's try 2. 2, negative 4. Negative 8, negative 5, negative 10. There's my 0 right there. Okay, once you get a 0 here, that means you found one of the zeros. Okay, so now we're going to factor it using the factor theorem like we did last time. Okay, now if 2 is a 0, then what is my factor? My factor is x minus 2. And then after I did the synthetic, I was left with this polynomial here, which is x squared minus 4x minus 5. Okay, let me factor this completely. Then I'm going to read the question again to make sure I'm doing what it tells me to do. What is this? Minus 5 and plus 1? Okay, now I have factored it completely. But they want me to find all the zeros. So they want me to figure out the actual x values when this is equal to 0. So if I make this equal to 0, what are my answers? X equals 2, x equals 5, and x equals negative 1. Okay, so I got all 3 of my zeros. It also means that at the beginning when I had done synthetic substitution, the 2 would have worked, the 5 would have worked, or the negative 1 would have worked. So if you find a different number than someone else for your first 0, that's okay, because on at the end you're going to have the same 3 numbers. Okay, now that we've seen it, let's go ahead and try the next one together. Okay, you can try to group it first. It's not going to work, but I do normally glance. This is x squared times x minus 8. That's not going to have an x minus 8, so I know it's not right. Okay, let me look at the last term and think about my possibilities here. Okay, now it's going to be positive, negative. Now 1 always works. 1 times 18. I could do 2 times 9. I could do 3 times 6. No, not 36. 3 times 6. Okay, so that's my list of possible numbers. Okay, I'm going to try one and see if it works. I normally start with an easy one, like 1. What's my goal? 1, negative 8, 21, negative 18. Let me bring down the 1. 1 times 1, 1, negative 7. 1 minus 7, 21 minus 7 is what, 14? 1 times 14, no, that's not going to work. Once you see it's not going to work, just stop, rewind. Let's try something else. What do I want to try next? I might try negative 1, 2, or 3, something really easy. Let's try a negative for a change. Let me try negative 1. Okay, 1 times 9, that's negative 1, negative 9, 9. What is that, 30? No, that's not going to work. Let's try another one. What should we try? How about 3? And if you already got it, just keep going. Oh, there we go. That one works. Okay, so I found a 0. Okay, once I find a 0, I can continue with the problem. So my first 0 was positive 3, which means my first factor is x minus 3. Okay, after I divided by 3, x minus 3, I was left with this polynomial, which is x squared minus 5x plus 6. Okay, let me go ahead and factor it completely. Okay, what do I times to get 6? 2 and 3? Negative. Okay, so my answers are going to be x equals 3, x equals 2, and I got x equals 3 again, which I don't need to list twice. Okay, so my answers are 3 and 2, which also means at the beginning when I was guessing, 2 would have worked and 3 would have worked. So your goal is just to find one that works. Okay, go ahead and find the practice problem. Try the practice problems out. Remember, if you find a different 0 than me first, your work's going to look different, but our final answer is going to look the same. Okay, for number 1, I got x equals 1, 3, and negative 2. Okay, go ahead and try 2. Okay, for number 2, my zeros were x equals negative 1, negative 5, and 3. Okay, and for number 3, my solutions were x equals negative 1, negative 4, and negative 2.